So let's talk about the product rule. First of all, you need to recognize before anything that this question is a product rule question. And how would you actually do that? The word product that you've learned from primary, year 7, year 6, 7, 8, 9, 10, 11, 12, has always meant to multiply. So the minute you've got an x times a function and you can't get rid of that, the two functions of each other, you're going to be using product rule. So for example, if you've got y equals 5e to the power of x, that's just normal differentiation because it's just y equals 5e to the x. And if I was going to differentiate it, I would write it as over dx equals, when I differentiate e to the power of x, I get e to the power of x. So it's just 5e to the power of x. Okay. Now, if you look at the ones in green, it's not just 5e to the power of x, there's an x there. And the minute that there's an x that you can't get rid of in differentiation, it's your product rule. Okay? We've got 5x times e to the power of x. Okay, so it's a product rule question. If I look at this, 5x squared times e to the power of x. Oh, so that's a product rule question. Okay, now just so that we've got a bit of an idea, let's go through a few more. So if I had, for example, 5x squared times ln x, they're multiplied by each other. It's a product rule. I can also have something like this, 5x squared minus 2x. On its own, it's fine. I can differentiate it. But the second they put anything in like ln x, you can't get rid of these other x's. It's a product rule question. Or if they multiply it by anything like sine x, for example, these two are multiplied by each other. It's a product rule. Other variations could look like this. If I just had 3 sine x, that's okay. We just differentiate that, right? But if it was 3 sine x, product rule. If it was sine x on its own, it's fine. But if it's sine x cos x, product rule. So the first step is to recognize that it's a product rule question. Okay, now that we've got that out of the way, let's look at the actual rule. This is the easiest, simplest way to remember the product rule. Okay, so here we go. You differentiate first, leave second, plus leave first, differentiate second. Once you understand this rule, everything else is simple. No matter how complicated, how ugly the question is, it doesn't matter because you know the rules. If you look at the formula sheet, you've got u, dv, v, uv raised, all of that. You don't need to worry about all of that. If you remember the rule, that's it. Differentiate first, leave second, plus leave first, differentiate second. Now let's look at a few examples and answer the questions. At the top, these are just a bit of a reminder. So if you need to just quickly look at them, let's move on. Remember all the differentiation? Let's go. So we've got y equals x times e to the power of x. They're being multiplied, so it's a product rule. So differentiate first. Let's just write dy over dx. Differentiate first, I end up with 1. Leave second, so leave e to the power of x. You just leave it as it is. Plus leave first, so let's leave x. Differentiate second. When I differentiate e to the power of x, what do I get? E to the power of x. And that's it. Easy peasy. Now, if you wanted to factorize, or if it says show in this form, you can simplify it even more. You can take e to the power of x as a common factor. So if I take e to the power of x, I end up with 1 plus, I've already got e to the power of x, so plus x. This is also correct. Let's move on to another one. So now we have another one. If this was y equals x times x plus 1 all to the power of 5, okay? One thing you need to remember is chain rule. If you don't know chain rule, just go watch it on another video. Maybe I would have had it by then, uploaded by then, but you never know. I'm so slow with these things. So anyways, do you chain rule the way you do it or the way you've learned it? I do it in my way. So we've got x times x plus 1 all to the power of 5. We've got two things multiplied by each other. I can't even get rid of this other x. So product rule. Differentiate first, so I end up with just 1. Leave second, x plus 1 to the power of 5, plus leave first, which is x. Differentiate second. Now notice the second differential is a chain rule. The way I do chain rule is I differentiate the outside and then I differentiate the inside and take it out. You'd have learned it in a different way maybe, so just do whatever you feel comfortable with. So this is what I do. I ignore whatever's here. I differentiate the outside, which is something to the power of 5. Multiply by the power, take 1 away from the power. So if I multiply it by 5, I end up with 5 over here. And then the bracket, minus 1 from the power, so it's 4. And I've got x plus 1 inside. Then I differentiate the inside. If I differentiated x plus 1, I would get just 1, so times 1. And that's it. I've done it. Now I just want to clean it up a bit. So I end up with x plus 1 all to the power of 5 plus 5x times 1, which is 5x. And then I've got my x plus 1 all to the power of 4. And that's it. I'm done. But if the question wanted you to simplify it more or show it in a certain form, I'm just going to show you how to do that, which is just algebra that you would have learned in GCSEs or learned anywhere else. I've got x plus 1 to the power of 4, which is common between this side and that side, these two terms. So what I can do is I can take x plus 1 out and factorize to the power of 4. In brackets, I've got x plus 1 to the power of 4. I've got 5 over here, so I'm just left with one of them. So that's x plus 1. On the other side, I've already got x plus 1 to the power of 4, so plus 5x. And I can simplify that to look like x plus 1 to the power of 4, 5x plus 1x, 6x plus 1. And that's also correct. Simple. Let's do another one with ln x. Maybe you could try doing this one yourself. Just a reminder, when we differentiate ln x, what do we get? 1 over x. Very good. So here we've got y. Y equals ln x. I know it's a product rule question because like, this x is going nowhere. It's just there. So I need to use the product rule formula. Differentiate first. So I just end up with 1. Leave second. So I end up with ln x plus leave first x, differentiate the second. When I differentiate ln x, I get 1 over x. So times 1 over x. And all I need to do is clean it up. So equals ln x, so the x cancel out, plus 1. And that's it. Lovely. One last one. Let's go. Another chain rule one. It's nice and cute. Same thing. Can I get rid of this x squared? No, because I can't multiply inside because there's a 3 over there. Right? I can't. So there's nothing. It's going nowhere. So I know it's being multiplied by it. And therefore, I know it's a product rule question. So if it said y equals this, let's do our dy over dx. Differentiate first. So I end up with 2x. Leave second. So I end up with x minus 1 all cubed. Plus leave first. So it's x squared. And then differentiate second. Now the second differential here, when I come to differentiate, is a chain rule question. So the way I do is I ignore this and I differentiate the outside, which is the brackets cubed. So if I differentiate that, I multiply by the power. So I multiply by 3. And then I've got my brackets, 1 away from the power, 2. And so I've got x minus 1. And then I differentiate the inside. If I differentiate the inside, what do I end up with? 1. So times 1. And that's it. Product all done. All I have to do is, so equals 2x, x minus 1 all cubed, plus 3x squared times 1 is 3x squared. And then x minus 1 all squared. And I'm done. If I wanted to factorize out as well, I could do that in this question as well. On this side, what do I have in common? I've got the x in common, and I've got the x minus 1 squared in common, right? So let's do that just in case you get those questions that say, show it in this form. Okay, so let's take out the x and take out the x minus 1 all squared as a common factor. I've already got an x here, so I'm left with 2. And I've got x minus 1 cubed. I've already got 2 of them outside, so x minus 1 plus 3x. I thought I was going to write on my head, but it's not because it's just finished with 3x. Okay, clean it up a little bit more. So I've got x times x minus 1 all squared, brackets 2x minus 2 plus 3x. And then I get x brackets x minus 1 all squared. And I get 5x minus 2. A little light bulb on my head because it's finished. And that's it. These are all the worked examples. Now you might be thinking, oh, there's probably horrible questions out there. You're just showing us these ones, but there's ugly exam questions. That's okay. It's still the same formula. You still do the same rule. Let's look at 3 of them. Let's look at 3 exam questions. Let's move me over here. Get out of here. Move in. So, hey,